Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry the Mystery of Molecules. Today's topic of discussion is nucleophilic substitution by fluoride. Now, first question may come, why this reaction happens? Or if you look at the condition, this X means OTS, Cl, Br are substituted by F. Is it violating the concept of nucleophilicity? Because we know that fluorine is a bad nucleophile whereas they are good nucleophiles. So why this different or anomalous reaction is observed? So we shall learn this thing in details, but before going to details, one MCQ in front of you. So I request you student, please pause the video and write your answer in the comment box, and definitely at the end of this discussion you will get the right answer. And remember, self-evaluation is essential for improvement. Now let's come to our main topic. So this is actually simply a nucleophilic substitution reaction, or more specifically if I say, it is an SN2 type reaction where this X means these groups are substituted by fluoride, which is acting as a nucleophile and produce this RF bond, and the source of this fluoride is this quaternary ammonium bifluoride salt. This. So before going to the main topic or mechanism, few important points. Please remember, this fluorine is not a good nucleophile. However, it's a milder base, so it is harder compared to other halogens like iodine, bromine, chlorine, etc. And in this case, due to the softness character, you can say that iodide is a better nucleophile than bromide, which is better than chloride, and which is better than fluoride. So in this case, fluorine is the worst nucleophile compared to other halogens. But why the reaction happens? This is because the stability of carbon fluorine bond. And why this carbon fluorine bond is so much stable? Because second row overlap. And proof of the statement is Teflon, because in Teflon there are CC and CF bond, and this CF bond is so strong that it doesn't allow something to stick on the polymer, and it is stable up in significantly high temperature. That's why we can use Teflon as cookware. I have already discussed in a dedicated video, you may visit. And remember, in this reaction we are reacting F minus, means F minus acting as a nucleophile. So this is a nucleophilic fluorination, and this is relatively easier compared to electrophilic fluorination, where we need to use F plus derivative reagent, which are very reactive costly. By the way, this concept is relatively new about this electrophilic fluorination. I've already discussed a dedicated video. You may visit for the lecture for better understanding, but I believe you may understand this nucleophilic fluorination versus electrophilic fluorination completely for the CF bond formation. Now let's look at the mechanism, how this reaction is actually happening. Before going to the mechanism, one point you must remember is this HF is means HF2 minus. Why it is formed? Because hydrogen bonding, means this hydrogen is in between the two fluorine atom. And why this is? Because this hydrogen bonding is so strong that it is very difficult to distinguish which bond is the natural normal bond and which bond is the, you may consider, hydrogen bond. Two bonds are equal. So in order to generate this F minus, which is the actual nucleophile for this SN2 type reaction, it is needed that we should use a base, and for that purpose pyridine is used, and the lone pair of pyridine is acting as a base for proton extraction. But how it does? It does little different way. Why? Because the strength of the hydrogen bonding. So for that purpose you can see two molecules of HF2 minus anion first react together, means in equilibration, and produces this F minus. Along with that it produces H2F3. And how this satisfied the concept of hydrogen bonding? You can consider that this is one HF, it forms hydrogen bonding with another HF, and this also forms hydrogen bonding with another fluorine minus. So you can consider in this way. So hydrogen bond, since the hydrogen bond is delocalized, means it's relatively weaker, consequently it is easier for the base to abstract the proton. Not only that, after the reaction also it produces HF2 anions. From that point you can say it is relatively easier, because from HF2 minus directly HF and fluorine minus generation is difficult, whereas this process is relatively easier based on my understanding. So in this way the nucleophile F minus is generated, and it participates in a SN2 type reaction and it leaves. And if you look at all the leaving group, means X, are relatively better compared to fluorine, so they leave and ultimately they produce RF. and in this context, as I told something before, this RF bond is very strong, so that's the main driving force for this reaction. And another point is that once this carbon fluorine bond is formed, it is difficult to break, because this carbon fluorine bond, the fluoride is a bad leaving group. Why? For example, you are doing this RBr reaction with this F minus source, so what it will produce? Br minus. So we can expect that this Br minus, since it's a better nucleophile, so it will attack this R from the back side and it will leave, so ultimately it will produce the RBr again and F minus. But student, this reaction is not possible. Why? Because F minus is a very bad leaving group, it's not a good leaving group like Br minus, so this reaction will not happen. So after certain time, the concentration of the product, means this RF, is expected to increase. In this way, reaction proceed in the forward direction. Now another question, you may think that, sir, we have KHF2, this salt, or ammonium bifluoride, this salt possible. Instead of that, why tetrabutyl ammonium salt is used? Here the concept of PTC comes, because PTC means phase transfer catalyst. See, this KHF2 or ammonium bifluoride, they are all salt, means inorganic compound, and the reaction medium is organic, pyridine dioxane. So it is expected that they may not be soluble completely, and if they are not soluble, how the reaction will happen? But this quaternary ammonium compound, means tetrabutyl ammonium salt, is actually, it's a salt, but because of the presence of this 4 quaternary ammonium tetrabutyl group, this is also soluble in the organic medium, and that is the basic of concept of this PTC. You may visit this lecture for complete understanding. So that's the reason why this quaternary ammonium group is used for this transformation. Now this is the reference where I've taken this information, you may visit. Now let's come to our MCQ. This MCQ is an example of aromatic nucleophilic substitution, and in this case the final product is the single substitution, better to say this, and this reaction happens through production of intermediate, that is, we may consider this nucleophilic attack, means this lone pair will attack here and it will open. So this is like a aromatic nucleophilic substitution. So this is the negative charge, this is the fluorine, and this is the nitrogen with attached. And by the way, student, after attack, this nitrogen will have a formal positive charge and proton attached, and this proton will be abstracted because of the base potassium carbonate and the solvent, means this potassium carbonate will act as a base and abstract this proton, such that this reaction can happen in the forward direction. Now a question you may think that, sir, aromatic nucleophilic substitution happens when in para position there are some group which have minus R effect like nitro. Why? In this case there is a fluorine, because fluorine has both minus I effect and plus R effect. This is reverse. But why this is happen? Because the minus I effect in case of fluorine is extremely dominant over its plus R effect. So overall, because of the presence of two fluoro group, these nucleus became highly electron deficient. That's why this nucleophilic attack is possible. And after that, what happens? It comes back and it leaves and produces this. By the way, I have already discussed aromatic nucleophilic substitution in details, so you may visit those videos for understanding. So mono substitution is the product. Now you may ask the question, that's not why not other option? This is because for option B you need benzene type intermediate, means this is this. To that benzene intermediate, these amine can do nucleophilic attack, then only this formation possible. But since benzene is not produced, so this is not possible. Let's come to the other option. So if you look at this di substitution, then it is expected to happen from the mono substitution. But see, mono substituted product is not an electron deficient because of the presence of this nitrogen which have plus R effect. So that's why aromatic nucleophilic substitution not possible here, and di substituted product formation not possible. So that's why option A is the right answer. So now this is the end of the discussion. I believe this video may be useful for you. Please write your opinion in the comment box, and I request you to please visit one of my another channel, Climate and Chemistry, where I upload global warming and climate change related videos. So thank you, stay happy, stay blessed, see you in my next video, bye bye.